To find root x, first draw AB equal to x in whichever unit you want, say centimeter. Then BC should be 1 centimeter if it is in centimeter, if x is in centimeter, 1 centimeter. Find the midpoint of AC, call it O. So OA is equal to OC. Placing the needle of the compass at O, construct a semicircle like this. So radius is OA equal to OC. From B, draw a perpendicular that cuts the semicircle at D. This BD will be root x. How? Here comes the proof. AB is x, BC is 1. So AC is x plus 1. O is the midpoint. X plus 1 whole divided by 2. OB. OC is x plus 1 whole upon 2. OC. From OC subtract BC and you get OB. So now you know OB. OA, OC, OD, they're all same. They are all radii of the same circle. Using Pythagoras theorem for this triangle, OD square is OB square plus BD square. X minus 1 by 2 whole square, then OD also I should put. We are trying to prove this. OD. OD is radius, same as OA, x plus 1 by 2 whole square. Any questions up to this point, let me know. Now A square minus B square formula. Yes, go ahead.
Yeah, sir. I just need to know how BD square became x plus 1 by 2 the whole square. I'm sorry, OD square.
OB is OC minus BC.
Yes, sir.
And OC is how much? OA. X plus 1 whole upon 2. BC is 1.
Yes, sir.
So when you subtract, you get x minus 1 by 2.
Yes, sir.
That's why you got square here. OB square, OB square.
No, sir. How did we get the OD square as x plus 1 the whole square?
OD square equal to?
How did we get the value of OD square? That's x plus 1 by 2 the whole square.
This is the radius. OD, OA, OC. They're all equal.
Okay, thank you so much.
Two x by 2, then 1. Taking under root, but length can never be negative, plus root x. So BD we have proved is plus root x. Any questions? Let me know. And by the way, you can use this method also to show root x on the number line. You know BD is root x. So you can take its measure using your compass. You can consider B as your origin, and then you can cut an arc here. And because construction is a standard procedure, even if x is in some decimal, it should not be a problem. If x is say 5.9, 9.25, still no problem. Construction procedure is similar. In many occasions, we want to get rid of root in the denominator. In many occasions, we want to get rid of root in the denominator if it is present, of course. Say for example, 2 by root 3. And I don't want root 3 in the denominator. So I employ a procedure, and that is called rationalization. Note that often we do not mind root in the numerator, but we do mind it in the denominator. This procedure is like this. We multiply by root 3, we divide by root 3. So we have 2 root 3, and root 3 into root 3 is 3. It is done. How can it be of real use? I can give you the example. Try to find out 2 by root 3 by your division process in this manner. And try to find out 2 by root 3 by calculating this. Multiplication is certainly easier than division, less time consuming. This can be found out in a rapid way in comparison to this. So there are some calculation advantages also to not to have root in the denominator but okay in the numerator. This was a very simple example. There can be more difficult examples. Say for example, you have got 3 minus root 2 in the denominator, and you do not want that. And here you multiply and divide by 3 plus root 2. Why 3 plus root 2? Because you can use a minus b, a plus b formula. A square minus b square, root is gone. In the denominator, it is gone. Numerator, it is there, which is all right for us. General rule is that if you have something like p plus root q, then multiply by this, divide by this. If you have just root q, multiply by this, divide by that. Whatever you choose to multiply and divide by, that is called a rationalizing factor. Rationalizing factor. You must have noticed the pattern minus sign, plus sign, minus sign. That pattern is repeated because that's the only way you can get a plus b, a minus b formula in the denominator. Any questions? Let me know. Rationalize the denominator is the question. Can you try it?
3 plus root 2 is the answer.
Make it rational.
3 minus root 2 is the answer, sir.
No.
Sir, 3 minus root 2 divided by 7.
So you have to rationalize the denominator. So use the rationalizing factor. Rationalizing the denominator means denominator should be rational. It is irrational right now. Right? Any questions? Increasing the difficulty level a bit. 8 plus 5 root 2 is irrational. Rationalize it. Make it rational. So what's the final answer?
Sir, 8 minus 5 root 2 by 14.
If anybody is having problem, then let me know. So what is the rationalizing factor here? 8 minus 5 root 2. What is the actual definition of rationalizing factor? If product of two irrational numbers is rational, then each one is called the rationalizing factor of the others. If product of two irrational numbers is rational, then each one of them is called the rationalizing factor of the others. How about handling a situation like this? No problem. Try this.
Root 6
Root
plus
6
5.
plus root 5.
Root 6 plus root 5.
Any questions? Let me know. How about this one? You have to rationalize the denominator. Don't bother about the numerator.
So 1. 1 by 1.
Anybody else?
Hello, sir. 4 minus 2 root 3 by 2.
Can you simplify it?
The, 2 minus root 3.
Minus root 3. That's the answer. Any problem? Let me know.
So please can you solve this on the board?
Denominator you have a square minus b square. You should be solved further now. Any questions? Let me know. Final answer is this. Rationalize the denominator.
So 17 minus 12 root 2.
Yeah,
It's correct.
17 minus 12.
Yes, any problem? Let me know. Okay, what about this?
So 2 and 1.
Yes, it's correct. Any problem, let me know. How about this?
So 31 by 19 and 10 by 19.
It's correct. Any problem?
Sir, can you do the working?
I can tell you how to do it. But you should be able to simplify on your own.
Yes, sir.
A square plus b square minus 2ab a square minus b square.
Sir, thank you.
Any other question?
Yes.
Next is in continuation only. What in continuation of what we are discussing, find a and b, that is, if they are rational numbers. Try this.
So 11 and 6.
59 minus 6, sir. So A is 59
11
and B root 3 is
B can't be rational.
6. So A is 59.
11. A is 11. Eleven comma 6 is right. Check your working. Any problem, let me know. Yes, any problem, or we proceed further? All right. Now we are changing the type of problem. In this problem, you have got two choices. Question is simplify this. You have got two choices. Independently rationalize them, rationalize the denominator independently and then solve, or right from the beginning take LCM and then solve. You can use both choices. If you take LCM right away, then it will become like this.
The answer is 3.
And now you can simplify.
The answer is 3.
Answer is 3. Other approach can be that you independently rationalize the denominator. This separately, then add the two. Any questions? Let me know. Try this. Here to simplify.
Sir, 42 by
42
11.
by 11. 42
42 by
by
11. Any questions? Next. If x is this much, find x plus 1 upon x.
Sir, 8.
8 is right.
Sir, can you show the working, please?
I can tell you the approach, then you try further. There are actually two approaches possible. One is that you take LCM right away, or second approach, you rationalize it. I am using the rationalizing approach. Not touching this part. A plus B, A minus B. 16 minus 15. Now you should be able to solve it. Any questions? Let me know.
Hello, sir.
Yes.
So this first one, the second one is the difficult one, or the difficult approach.
Why didn't you try it?
So I did.
I think taking LCM, if you go for LCM approach right from the beginning, then the problem of denominator will still remain. 4 minus root 15 will still be there in the denominator after you take LCM, right? It will look like 4 minus root 15 whole square plus 1 divided by 4 minus root 15. So later on we may have to rationalize. In this approach we are rationalizing right now.
Yes.
You don't have to answer it right now. That's your assignment. We stop now.